Have you ever wondered how a tree can stand tall and proud, defying the forces of nature? Or why the leaves rustle in the wind as if they're whispering secrets from one to another? What if I told you that the world of physics is intricately woven into the very fabric of trees? That's right. We're diving into the wild, wacky, and wonderfully weird relationship between physics and trees. So grab your favorite beverage, settle in, and let's get ready to branch out into this fascinating topic. First off, let's think about gravity. You know, that annoying force that keeps us grounded, literally. How does it affect trees? Picture this. A sapling, just a tiny little thing, is fighting against gravity with all its might. It stretches its little leaves toward the sun, yearning for that sweet, sweet sunlight to fuel its growth. But here's the kicker. Gravity is always pulling it down. So how does it manage to grow tall and strong? This is where physics struts in like a peacock, ready to show off its feathers. Trees have this incredible ability to convert sunlight into energy through a process called photosynthesis. But they can't do it without water and nutrients, right? So how do they pull water from deep underground, defying gravity? Meet capillary action, the unsung hero of the plant world. Water travels through tiny tubes called xylem, and thanks to capillary action, it can defy gravity, moving upwards against the pull of the earth. It's like a mini superhero story happening right beneath our feet. So the next time you see a tree, remember, it's not just standing there, it's engaged in a constant battle against gravity, using physics to pull off its miraculous feats. Now let's talk about wind. Ever been in a storm and watched trees sway back and forth? It's like they're dancing, isn't it? But there's more to that dance than meets the eye. When the wind blows, it exerts a force on the tree. This is where the physics of motion comes into play. Trees are designed to bend and sway instead of breaking. Their flexibility is a result of their structure. The trunk, branches, and leaves all work together to manage the forces acting upon them. If a tree were rigid, it would snap like a twig in a strong gust. But trees are smart. They've evolved to be flexible, using physics to adapt to their environment. But wait, there's more. Have you ever thought about how trees communicate? Yes, you heard that right. Trees are social beings. They communicate through a network of fungi in the soil, often referred to as the wood wide web. This underground network allows trees to share nutrients and even warn each other about potential threats. It's like a secret society of trees using chemical signals to relay information. But how does physics tie into this? Well, the diffusion of these chemical signals through the soil is governed by principles of physics. The speed at which these signals travel can affect how quickly trees can respond to threats, like pests or diseases. So the next time you think about trees, remember they're not just standing around. They're engaged in a complex communication system, all thanks to the laws of physics. Now let's shift gears and talk about the structure of trees. Have you ever noticed how some trees can grow to be incredibly tall, while others remain short and stout? The height of a tree is determined by its structure, which is a perfect example of physics in action. The trunk of a tree is a marvel of engineering. It's designed to support the weight of the tree while also resisting bending and breaking. The way the fibers in the wood are arranged allows it to withstand immense forces. This is where the concept of tension and compression comes into play. The trunk experiences compression forces at the bottom, where it supports the weight of the tree, while the upper part experiences tension as it reaches for the sky. This balance of forces is what allows trees to grow so tall without collapsing under their own weight. And let's not forget about the leaves. Those green little powerhouses are not just there for decoration. They're essential for the tree's survival. The surface area of leaves plays a crucial role in photosynthesis, but it also affects how trees interact with their environment. The way leaves are arranged on a branch is a perfect example of physics optimizing for maximum sunlight exposure. This arrangement, known as phyllotaxis, is determined by mathematical principles that ensure each leaf gets enough light without shading its neighbors. It's nature's version of a well-organized office space where everyone gets their fair share of sunlight. Now let's dive into the world of sound. Have you ever heard the sound of wind rustling through the leaves? It's a beautiful, soothing sound, almost like nature's music. But did you know that the sound of wind in the trees is a result of physics as well? The shape and arrangement of leaves can affect how sound waves travel through the air. When the wind blows, it creates vibrations that can be heard as sound. The frequency and amplitude of these vibrations depend on various factors, including the type of tree, the arrangement of leaves, and the speed of the wind. So the next time you're out for a walk in the woods, take a moment to appreciate the symphony of sounds created by the trees. It's a concert of physics playing out in real time. Now let's tackle a fun question. Have you ever considered the role of trees in climate change? Trees are often referred to as the lungs of the planet, and for good reason. They absorb carbon dioxide and release oxygen, playing a crucial role in maintaining the balance of our atmosphere. But how does this relate to physics? The process of gas exchange in trees is governed by diffusion, a fundamental principle of physics. The efficiency of this gas exchange can be affected by factors like temperature and humidity, which are also influenced by physics. So, trees are not just passive players in the environment, they actively participate in the physics of our atmosphere. And here's a thought. Have you ever thought about the life cycle of a tree? From a tiny seed to a towering giant, trees go through various stages of growth. Each stage is influenced by physical factors such as light, water, and nutrients. The growth rings in a tree can tell us a story about its past, revealing how environmental conditions have changed over time. This is a perfect example of how physics intersects with biology to create a fascinating narrative about the life of a tree. Now that we've explored the wild world of physics and trees, let's circle back to those questions we started with. How does gravity affect a tree's growth? It's all about that battle between gravity and capillary action, allowing trees to pull water from the ground. How do trees communicate? Through a network of fungi using chemical signals that rely on the principles of diffusion. Why do some trees grow tall while others remain short? It's all about the balance of forces acting on the trunk and the optimized structure of leaves. And finally, how do trees contribute to climate change? By absorbing carbon dioxide through a process governed by physics, they play a crucial role in maintaining our atmosphere. So the next time you walk past a tree, take a moment to appreciate the incredible physics at play. These magnificent beings are not just a backdrop to our lives. They're a testament to the wonders of nature and the laws of physics. They stand tall against gravity, dance with the wind, communicate through secret networks, and play a vital role in our environment. Trees are living proof that physics is not just confined to the classroom, it's all around us in the very air we breathe and the ground we walk on. So let's give a round of applause to the trees and the physics that makes them so extraordinary.